Hello students, we are finishing up the flood module. We're in activity 3. We're on page 5 where it says flash flood. In the two models that you've used in this activity, you observe that floods can occur two ways. First, when rivers overflow, and second, when rainwater stays on the surface and the ground cannot absorb it. Watch the video below about flash floods and then answer the questions. Floods are the most common and widespread of all weather-related natural disasters. Each year, more deaths occur to flooding than from any other thunderstorm-related hazard. Floods can happen during heavy rains, when ocean waves come to shore, or when snow melts quickly, or when dams or levees break. Flash floods are the most dangerous kind. They combine the destructive power of a flood with incredible speed. Densely populated areas are at high risk for flash floods. You can see there are permeability issues here. Buildings and pavement reduce the amount of rainwater absorbed. As little as 6 inches of fast-moving water can sweep most any vehicle off a roadway, so don't drive over standing or running water. Mountains and steep hills produce rapid runoff, and that can be a hazard to campers because streams rise quickly. They can create a risk for those who are camping or recreating along rivers and streams. Don't camp next to a river, please. NOAA and NSSL have developed a cutting-edge system for predicting when flash floods will occur. They're watching out for us. The multi-radar, multi-sensor system provides rainfall rate estimates every 2 minutes. They're using topography, so the measurements are combined with surface models. You can see there's a lot of steep stuff going on in that map within flooded locations and simulated hydrographs, the FLASH system. FLASH helps forecasters know where to focus attention when issuing flash flood warnings, so they can be more specific. If you sign up, you can get text alerts when a flash flood might occur. Go to nssl.noaa.gov to find out more. So let's think about the video. Why are flash floods more likely to occur in developed areas than farmland? Hint, think about the flood diamond, especially about permeability. Check all that apply. Developed areas often have flatter topography. Developed areas receive higher rainfall. Developed areas tend to have lower water tables. Developed areas have fewer permeable surfaces. So, explain how permeability relates to the likelihood of flash flooding. If you need some help thinking about permeability, remember in our previous video, we had a towel kind of stand in for the absorbing or the highly permeable surfaces of grass, forests, farm fields. They can soak up water just like a towel. Things like roads, sidewalks, roofs, parking lots don't absorb water, and that water runs off and can flood rivers if you don't have flood mitigation in place. So explain how permeability relates to the likelihood of flash flooding. Well, when water falls on impermeable surfaces, all that water falling on your road, your roof, your sidewalk, your parking lot has to go somewhere. And if you don't have rain gardens or holding ponds or stormwater management areas that are permeable, you're going to get flooding. You're going to get all that water that falls on impermeable surfaces, that falls on pavement, flooding into your local lake or stream or river, and that is going to increase your likelihood of flooding a whole bunch. All right, greening up the riverbanks. The relationship between permeability and flooding is important to consider in many cities throughout the United States. Like Kansas City, St. Louis is another large city built on floodplains on the Missouri River. In fact, St. Louis has 3 rivers running through it, including the Mississippi. Large areas of low permeability surfaces tend to increase the severity of floods in St. Louis, and they've tried to combat this problem. Look at the picture below. It shows the Gateway Arch in St. Louis on a sunny day. It also shows a lot of green along the riverbanks here. Which of the following do you notice about the area between the river and the buildings? The city buildings are right at the edge of the river, or there's a grassy park between the river and the city. Do you think it would be a good idea to put some buffer in there before, or would you want to build your house right here next to the river, knowing that river can flood because there's a lot of impermeable surfaces in St. Louis? It's a city. It has a lot of pavement and parking lots and roofs that don't absorb water. Explain how the green space St. Louis developed between the river and the city helps decrease the risk of damages caused by flooding. Well, if you assume the river is going to flood, and you know where the floodplain is, the floodplain is the area that tends to get covered by water in a flood, you can avoid putting buildings in the floodplain. And if there are no buildings, there is nothing to damage. Maybe not nothing. You might, if you have some parks, you might damage some of the structures in the parks, like railings or walkways, or minor damage, but you're not flooding buildings and homes, and you're not displacing people, you're not having to evacuate. It's much simpler if you leave the edges of the river devoid of things that will get flooded. So if the river does flood, it's okay. Here's an example of a park along the Mississippi and Minnesota rivers, which often floods. This is a special forest called a floodplain forest. These trees can stand being flooded for short times and still live. Many trees can't survive that kind of thing, and so they'll die if their roots are too wet for too long. This is me standing next to a pole in this park that shows you the different flood levels. This is 1965, I believe. I'm not sure what the dates on these. These are more recent floods. So you can see that this park often gets underwater, but it's a great thing to be along the river because there are no buildings, or there are just a few like picnic shelters. And so not much is damaged if there's a flood. So question 23 relates to the flood diamond. Well, any one factor in the flood diamond could cause a flood. What combinations of conditions will produce the most extreme floods? Fill in the blanks with high or low. So think about precipitation. Should there be a lot of rain for a flood, or just a little bit? The level of terrain, should it be flat so the water can spread out, or very mountainous so the water just runs off? The permeability, is it going to be high, or is it going to be low? If you have a lot of pavement, is that going to lead to more flooding because it's impermeable? Or are you going to have more flooding with a permeable surface, something that absorbs water? Like in our model, it was a towel, but it would be grass or farm fields in real life. And then the water table, are you going to have more chance of a flood if the water table is high? So you just have to add a little bit of rain to get a flood, to overflow. Or should the water table be low, so you have to add a lot of water before you get a flood? Which one of these situations is going to result in a flood more quickly with less water? Okay, when you're ready to print out your work, you go to the last page right here. After page 6, there's a little page. Scroll to the bottom, hit Show My Work. You'll have all your questions from activities 1, 2, and 3 in a document here. Then at the very top of your screen on an iPad, you want to find this little box here. Click that box. You'll see a menu that says Options in tiny blue text at the very top. Click Options and then PDF, and then back out and click Notability, and you'll download the whole thing to Notability. You will have activities 4 and 5 in there as well with no responses, and that's okay. Just hand in activity 1 through 3 for now. Thanks so much for watching. I'll see you in the next video for activity 4.